And let's see how far we get. We are starting with section 9.5 today, and we are going to skip around and do as much as we can of 9.5. We're going to get the main ideas. We won't be doing every single problem. Alrighty? So here we go. 9.5 is about taking the terms of the sequences that we've been studying and adding them up. Okay? So the first thing I want to do is get the formulas up here on the board for you. There's a place for you to write them in your notes on the next page, where it says time out. Here are the formulas. So I'm going to give you the formulas. Okay? There are 3 of them. So your arithmetic sum. What does arithmetic mean? You get from term to term by adding the same number. So if you have an arithmetic set of numbers and you want to add them up, your formula is this. All the letters mean the same as they have always meant. The S stands for sum. N is the number of terms you're adding up. So if you had 10 terms to add up, then N would be 10. That's that N. A sub 1 stands for what? What does it always stand for? The first term. And then if I were adding up 10 terms, A sub 10 would be the last term, the 10th term. Okay? So if it's arithmetic, that's your formula. If it's geometric, then this is your formula. You do not have to memorize these. All the formulas will be given to you on the exam and on the quiz or test or whatever we end up having here. Okay? Now, again, all the letters mean what they've always meant. So S sub n, if there were 10 terms that you were adding up, first term minus first term times the ratio. Remember, in a geometric sequence, we get from term to term by multiplying. That's called the ratio to the 10th power or whatever, however many you're adding, and then 1 minus the ratio. All right? Now, sometimes we have infinite geometric sequences. If they are infinite, then this is the formula. This is for it. How will I know if they're infinite? Hey, you guys, welcome Mr. Rushka.
Mr. Rushka.
He's been filling in. Yeah, the math teacher, he's been ill and he's been filling in. If the sequence is infinite, then I don't know how many terms there are. It goes on forever and ever. So notice there's no n in this formula, right? Okay, so arithmetic, geometric, infinite, geometric. All right, now we're going to do some examples of all of those. So we're going to skip number 1 for a second, and we're going to go to, we're going to skip a long way. We're going to go to the word problems, which is number 7. Doesn't appear that I numbered the pages, so find number 7 where the word problems start. Okay, so here we go. When Super Bowl sprang upon the scene, kids across the United States, okay. How far does it travel until it stops bouncing? Okay, so I'm going to draw a little picture of this. The ball is dropped from a height of 2 meters. Okay, so here's the ball, dropped. Now, according to the problem, what does it do? It bounces up. And how far does it bounce up? 90% of the distance it fell. So 2 times 0.9, which you can figure out, 1.8. All right, so I dropped it, it bounces up. Now what does it do? It goes back down. And how far will it go down this time? 1.8 again, right? Isn't it going to come down the same distance that it just went up? Okay, so now, here it is. It comes down. What does it do now? It bounces back up. And how far is it going to bounce up this time? 90% of 1.8. And then it's going to come down that distance, and then there it goes, right? Now the question is, how far does this ball travel until it stops bouncing? Now, because we're running out of time, we're doing this crash course. This is a tough problem. There's some stuff, you gotta stop and think about this for a minute. Let's look at just the downs for a minute. If we look at just those numbers, the first one was 2, the next one was 2 times 0.9, which we can figure that out. The next one was that number times another 0.9, and so on and so on and so on. What kind of a sequence of numbers is this? Geometric. Because to get from term to term, I am multiplying by 0.9. So my ratio is 0.9. Now these are just the downs. I've got 2 things going on in this problem, so I'm looking at just the downs. Okay. Can I add those up? Well, I have a new formulas over here that add these things. It's geometric. So it's either this one or it's this one. These are the geometric formulas. Which one do you think it is, sir?
Wouldn't it be infinite?
Yes, because what do I not know?
You don't know when it's going to stop.
I don't know when it's going to stop. Theoretically, it doesn't really stop, but we know it will eventually. Yeah. But theoretically, it doesn't because it keeps bouncing back up a little bit, right, every time. So I'm going to use my geometric sum formula, infinite geometric sum formula. Now remember, these are just the downs. So formula says take your first term, which is 2, and divide it by 1 minus your ratio. Now those of you that type stuff into your calculator right here, which is fine, if you want to do that, remember, when you got 2 things in the denominator like this, if you're going to leave it like this, you got to put that in parentheses. I prefer to go ahead and subtract. What's 1 minus 0.9? 0.1. I prefer to do that. And you should get, hopefully, 20. All right, so 20 meters, what do you have? 20 meters. Now, this does not answer the question, though, because remember, this ball is going up and down, right? So now I've got the downs figured out. So now I need to do the ups. Now, I've got a couple of options here. What do you think? What do you think about the ups? Look at my picture, that might help. I've done the reds. The reds are added up, they make 20. What do you think about the blacks now?
Isn't it times by?
Patrick?
I was gonna say 1.8.
Okay, so Patrick says, let's just do exactly what we just did, but let's start with the first up, which is 1.8. So 1.8 over 1 minus 0.9. Thank you. Which again, if you type it in like that, fine, use parentheses, or 1.8 divided by 0.1, you get 18. So the answer to the question is 38. Now, did anybody have a different thought for those ups? There is nothing wrong with that. That is absolutely fine. Did anybody have a different thought though, maybe? Do the downs and ups match exactly? No. What's different about the downs and the ups? The ups don't have the original 2. So if the downs and the ups are exactly the same, except for the original 2, doesn't it make sense that the ups would be 18? 2 less than the downs? So you could do it that way too if you wanted to. But what he did is absolutely fine, perfect.
So will it always mathematically like make it out to be like it's 2 less than the original?
Well, it's 2 less because that was the initial
Right,
height.
so if it's like 4, it'll be 4 less.
Yes.
Okay.
Unless, sir, the ball is thrown. If the ball is thrown, then the ups and downs will be exactly the same, right? Okay, all right, that's good, good. All right, number 2, B. The first row of seating, in section J of this arena has 7 seats. So we have the seats, we have 7 in the first row, and there are 25 rows. Okay, so here's the first row, and we have a second row, and third row, and fourth row, and so on. Each row contains 2 more seats than the row preceding it. So if the first row has 7, how many does the second row have? 9. And then the next row would have 11, and so on, and so on, and so on, right? Arithmetic or geometric? Arithmetic. I need to add them all up. It says how many total seats are in this section. So would you agree I'm going to add all these up?
Yes.
It's arithmetic. I only have one formula to worry about. Here it is. All right. How many am I adding up? I want to take the sum of all these terms. How many terms are there? 25. So 25 over 2, I'm just doing my formula, just plug it in. What's A sub 1 stand for?
7.
That's the first term, which is 7. Oh no. Oh no. What's wrong? What do I need? What do I need to know?
Go to the last one.
I need to know A sub 25, which is, if I kept this going, it would be the 25th number in that row. Oh, shoot. One option is to just keep adding 2 until I get out there and hope like heck that it's not 250 rows the next time I see this problem. What else could I do if I want to find the 25th term of that sequence? I know we've packed a lot in, but it's what we did last time. Remember this formula? Remember that one? What does that formula do?
It finds the last.
It finds the term I'm looking for. So the 25th term of the sequence, which is what goes here, this is the 25th term, the last term of my addition, is the first term, which is 7. What's my common difference?
2.
2. And n minus 1 would be 24. So let's see, what is that? 55, did I add right? It's gonna be embarrassing if I didn't. 25 over 2,
It's 52.
7 plus 55?
It's 52.
Oh,
It's 55.
No, it's 52.
48 and 7, isn't that 55?
Yeah, I hit the wrong number.
Okay. All right, so now I should be able to get my answer. Did you get 155 seats? As your total? Oh, no, never mind. Sometimes when I use my calculator, that first number doesn't come out when I hit it. I think it says my calculator's so old. What'd you come up with? 775, does that sound better?
775, yeah.
So what's the moral of that story? Sometimes, and it happens with this formula. This is the one it happens with. Sometimes you don't have what you need. So when I didn't have what I needed, I went back to my old formulas, and I'm giving you all of them. You don't have to memorize any of them, you'll have them all. I go back to my old formulas, and that will help me fill in the missing pieces. Be on the lookout for that. All right, C. Pat designs a patio with a trapezoid-shaped deck consisting of 16 rows of congruent tiles. The numbers of tiles in the rows form an arithmetic sequence. The first row contains 15 tiles, and the last row contains 30 tiles. How many tiles are used in the deck? All right. Okay, so what do you think? Let's see. Yeah, Alexis.
I think it's an arithmetic sum with it going up by 1
Okay. How do you know that?
Because you're starting out at 15 for row 1, and then you're going up to 30 in the rest of the 15.
So, are you following what she's talking about? No. What she's saying is, you know what, she's always thinking. She says, okay, so I got 15 tiles in the first row, and I've got 30 in the last row. And they form an arithmetic sequence, which means that they are going up, right? By the same amount, all the way to the end. We know that there are 16 rows. Okay, so in other words, this is your first row, that's your 16th row, so there's a bunch of rows here in between, right? And we're going up by the same amount each time. So she says she thinks they're going up by ones. Isn't that what you said? So she thinks the common difference is 1. What do you think? Well, Alexis, let's think about this for a second. Don't I want to know how many tiles are in the deck altogether? So I'm going to use my arithmetic sum formula. Do I even need to know what the difference is? No. What do I need to know? To use this formula, I need to know how many I'm adding up. How many am I adding? 16. What else do I need to know? The first one and the last one. Don't make the problem harder than it is. Don't make it harder than it is. Don't I have exactly what I need to answer the question? You can type that in and get the answer. All right, let's look at the next one. Donovan, this is exciting stuff. Stay with us here. We're gonna have a quiz or a test or something over all this, so we gotta make sure we got it under control. All right, Trey has decided he'll begin saving money every day. He sets aside 40 cents the first day, 46 cents the second day, 52 cents the third day, and so on. How much will he set aside on the 37th day? Let's think about it. Let's figure out what formula we're going to use. Think about what are we trying to figure out. Abby?
I don't think I'm right anymore.
Go ahead.
I was just gonna say that I think it's arithmetic.
That is 100% right. Okay, what else?
I thought it was going up by 6.
Okay, it appears to be going up by 6, perfect.
So I think the equation would be the arithmetic one with the x and equals n over 2.
Okay, so how many days am I saving? Well, now, we gotta be careful, because there are 2 separate questions here. Question A is not a sum, Abby. Do you read question A and read question B?
Oh, is it the a with the little place?
The grammar is different. Does everybody see that in these 2 questions? The grammar is different. Because for question A, it says, how much will he set aside on the 37th day? Doesn't that just mean find the 37th number in this list? So the 37th number in the list is just a term, not a sum. I just want to know, if he puts this much in his bank on day 1, and this is day 2, and this is day 3, how much is he going to put in the bank on day 37? So the 37th term will be 40 plus 6 times 36. Would you agree with that? Did you get 256 cents?
Yes, $2.
Now, does everybody understand that's the amount of money that he deposits in his piggy bank on day 37? Now, read question B. That's different. The grammar of the sentence is different. How much will he have saved? Don't you want to add all those up?
Yes.
So that one, Abby, I'm gonna erase these, you guys have them written down. That one, Abby, is a sum. Only we're adding up actually 100 days. Agreed? So that formula says 100 over 2. First day was 40. Oh, shoot. What goes here?
The last one.
Well, in this case, it'd be the 100th term, and I don't know that. That's the last day's savings, so what am I gonna have to do? Abby? I'm gonna have to do this again, except I'm gonna put 100 here. So the 100th term is 40 plus 6 times 99. $634. And that's not the answer to the question, that's what goes in here, right? So now I can answer the question. Now remember, you got a big number, I hope, 33700. Now remember, what's the unit on that? Cents. So we probably, most people don't talk about 33,000 cents, so we probably should change that to dollars. So what will be the answer? $337, right? That's a lot of money. But nothing like question E. Okay? We're gonna do a couple more kids, and then I'm gonna have you get your homework out. We're gonna crank through that and get that done for you. Okay? So let's do a couple more of these. Question E. Grace decides that she too is gonna start saving. Okay? Her plan is to save 4 cents on the first day, 12 on the second day, 36 on the third day, and so on. So this is Grace's plan. Trey's plan was what it was. This is Grace's plan. Question 1. How much will she set aside on the 37th day? Sir?
So that, if, wait, how much was she set aside? So would we just use, we would use the A 37.
37, yep.
Yeah, A sub 37 equals, 4? No.
4.
Oh, yeah, 4. I'm like looking at the formula. plus,
No,
no?
no, this formula I don't have on the board, we haven't used it yet today. What's our geometric term formula? Anybody remember? A sub 1, R to the n minus 1, that's exactly right. Now, I'm gonna give you these formulas, but I'm not gonna tell you what's what. You're gonna have to figure out which one to use. So on the 37th day, I am simply looking for the 37th number in this string. Your term formulas, A sub n term formulas, give you the term. So this is geometric. So the formula says take the first term times the ratio to the n minus first. Oh my land. What'd you get?
6.003785
Times 10 to the 17th, all right? So Grace is in for some trouble here because that's a lot of money. But just for fun, let's go ahead and answer the second part. How much will she have set aside after saving for 100 days?
Wouldn't that be the geometric sum formula?
That's the geometric sum formula. So she's saving for 100 days. Look at your formula. It says take the first term minus the first term times the, oh Lord, the ratio to the 100 over 1 minus the ratio. Now, I think you know this is going to be crazy huge, but I want to make sure you understand how to type it in on your calculator. I would suggest that you go ahead and make that a -2 to start. Just do that subtraction, 1 minus 3. And then when you type it in, 4 minus 4 times 3 to the 100, it equals. And then divided by -2. Did you get 1.03 times 10 to the 48?
Mhm.
Yeah. Obviously, that's an impossible problem, but we're having fun using our formulas.
When you say it's impossible, you guys just can't have it.
Well, this is in cents, so 10 to the 48 cents would be 10 to the $46. I don't even, is there that much money? I mean, I can't even
Yeah.
comprehend that, no, it's not possible.
Oh, well.
She couldn't save that much money. Even like the richest people in the world don't have that much money. All right, let's pick one more. How about G? Mrs. Ford asked Michael to do 5 problems on day 1, 9 problems on day 2, 13 problems on day 3, and so on. Do you see what's going on?
Yes, you're adding by 40.
Yep, so it's arithmetic. If Michael did 538 problems on a certain day, did he stick to the plan? If so, which day is it? So basically what this question is asking me is 538 actually a number in that list? If I kept going, would 538 be a number in that list? Anybody have an idea how we might figure that out? Anybody besides my 2 favorite students that answer every question? Ben, you got any ideas? Wild guess? Ethan?
Can you put all the information into this, sum thing and just solve for that?
You can put all the information into a formula, but I don't think I'm going to use the sum formula. Because am I adding all these up? 538 is how many he does on a particular day. So I don't know how many they all add up to. I just know that on some day, he's doing 538. So we've got arithmetic, and it's not sum, So I guess the only option I have is this formula right here. The last term that I'm concerned about is 538. The first term is 5. The common difference is 4 and minus 1. Look at that. Think about that. Does that make sense to you? Now before we solve it, is that solvable?
Yes.
Yeah, everybody can solve that. That's solvable. But if this is one of the terms of the sequence, if it is like the 70th term or something, then what do I know about my answer? What kind of answer will I have to get? A whole number. I gotta get a whole number, don't I? I can't get 42.6 as my answer. N is a term number. N is a term number, like the 37th or the 100th. I want to know what N is. Okay, let's solve it. What'd you come up with? Well, I've been blabbing. Have you been solving?
4.25.
Uh-oh. 134.25?
Yeah.
Is this a term of the sequence? No. So he did not stick with the plan. He freelanced at some point.
So initially, before like we did the formula thing, I just divided 538 by 4. Like I did 538 divided by 4, and then didn't get a whole number. Could that work, or would that just be a lucky that doesn't work?
Can you tell me why you did that?
Because technically, like if we do it, it's repeated addition, so it's multiplication. So then I just divided it by 4
Okay.
to see if it's in like.
Okay, is 13 divided by 4 a whole number?
Technically, no. Okay.
No, technically about it, but it's part of the sequence, right?
Yeah. Okay.
So I think you think twice about that.
Okay.
Now, there is a division that happens, but it isn't the term. It's the term minus the starting point. So
Right.
if you did that, if you took 538 minus 5,
And
that
then-
needs to be divided by 4.
Okay.
Yeah, that will work. Whoops, I got the wrong homework. Let's grab 9.5 homework. And we have a crash course in this. Let's see if we can get this done. And if we all keep our heads up and pay attention, we won't have to turn this homework in. We're all gonna do it together and we're all gonna get points for it if we all have it and we're paying attention. We're getting out our homework, Kylie. 9.5. By the way, congrats to girls lacrosse last night. Total blowout. Who else do I have? Anybody else in the play lacrosse? No? All right. Here we go. Number 1. When George graduates, he's going to get 2 job offers. Company A gives him a starting salary of this. So Company A gives him $32,500 and raises of $700 a year. Company B gives him $22,950 and 8% per year. Okay, everybody understand what's going on? This could be you someday. This is an arithmetic sequence. Would you agree? Because every year it's going up by the same amount. So the question is, where will he earn more money in his 5th year? So in other words, what is the 5th term of this sequence going to be? This is year 1. We're going to add 700, add 700, add 700. Well, you can do that, but let's use our formula. For arithmetic, the 5th term will be our first term plus the common difference, which is 700 times 4. Would you agree with me? All right, how much money does he make? $3,950. 35,300.
Mhm.
So with job A, he's gonna make $35,300 in the 5th year. All right, let's talk about job B. Now, would you agree that it's going up by 8%? So it's not going up by the same amount every year, right? This is geometric. Now, here's the tricky part. What's the ratio?
0.08.
No, because what happens if you multiply by 0.08?
That's right.
If they walked in and said, hey, we're gonna multiply your salary, Mrs. Ford, by 0.08, I'm mad. Because doesn't it go down?
Divide by 0.08.
If they're gonna give me an 8% raise, we gotta multiply by 1.08. Agreed, guys? Okay, that's a biggie, that's a biggie. Make sure you understand that. So my starting salary is $22,950. Any guesses what my actual starting salary was back in 1981
For a 4-year?
for a 4-year?
Are you wanting us to guess?
Yeah.
20, 30?
I was about to say 13, 14, 15.
$6,800.
Oh,
$6,800.
A year?
But hey, never fear, never fear. They also, because I was the newbie, young, 22, didn't know what I was doing. They talk you into everything. Don't they, Mr. Rushka? They talked me into doing the yearbook. So I made $6,800, but they paid me $400 for doing the yearbook. So I actually made $72.
You were
And the sad part is, so think about $7,200, think about taxes coming out and all that stuff and divide it up. So I get my first paycheck. Here I am, I'm newly married, here I am standing in our apartment. My husband took a picture of me, I'm standing there with my first paycheck, he's so happy. It was like $12 or something. All right. Okay, back to the problem. Back to the problem. So we decided we're gonna multiply by 1.08. I erased my formula, but my exponent is n-1, so that's gonna be a 4, because I'm doing it in the 5th year. So 22,950 times 1.08 to the 4th.
31,250.
So $31,223.22. So, who's this guy, George? If George is only gonna work at this place for 5 years, then man, he better take plan A, right, job A? But we have observed, think of that Grace's saving problem we did. Geometric sequences grow really fast. So at some point, would you agree, this is gonna catch up? So if he stays 41 years like I have, this would definitely be the plan to take. Right? Okay. All right, so, now, which job should he take if he is going to stay with the company for exactly 10 years?
Isn't it the same thing with Princeton?
Okay, now wait, let's think about this for a second. It doesn't say, will he make more money with A or B in the 10th year? It says he's gonna stay for 10 years. Don't we wanna know the total he makes in those 10 years? Because he could actually make more in the 10th year here, but not enough to catch up for all the other years that he made more with job 8. Am I making sense? Do you understand what I'm saying? So this question should be decided on how much he has accumulated. So sum. So for job A, which is arithmetic, the sum of 10 years is 10 over 2 times the first year, which is 32.5. Oh, here it is again. What goes here in this formula?
The last one.
So that would have to be a sub 10. So I'm gonna have to figure that out. So the 10th term is 32.5 plus 700 times 9. Am I going too fast? Does that make sense to everybody? So 32.5 plus 700 times 9, 38.8. So over that 10-year period that George works for Company A, he would make a total of $356,500. Somebody match that for me so I know I didn't.
I got that.
So that's a total that he makes over those years. Now, what if he went with Company B?
It's geometric.
It's geometric. So that formula says, take the first term, which is 22,950, minus the first term, times the ratio, and what did we say the ratio was in this?
1.08.
1.08, to the 10th, over 1 minus 1.08. And this is gonna tell me how much he makes all together in 10 years. So this is the formula. I like to go ahead and divide or subtract this, so negative 0.08. 22,950 minus 22,950 times 1.08 to the 10th. Make sure you hit equals. Hit equals, I can type all that in. And then divided by negative 0.08. I got 332,466.61. So even though he may have made more in that 10th year, I don't know if he did or not, overall, he hasn't made more. So if he's gonna work there exactly 10 years, he needs to stick with Company A. Everybody okay with that? All right. Number 2, Brenda does 18 factoring problems on Monday, 21 on Tuesday, 24 on Wednesday, and so on. This is number 2 in the homework. Everybody with me?
Yes.
How many will she do 2 weeks from her first Monday? And then question B, how many will she have done by that day? So do you understand the difference in the questions? What is question A asking you for? One of these?
Yes.
And then question B wants you to add them all up. Now, what makes this problem tricky is you gotta figure out which one of these you're looking for. Donovan?
Wouldn't it just be 14?
That's everybody's gut feeling. And let's talk about that, Donovan. Donovan says, listen, we wanna know 2 weeks, let's say 2 weeks from today. So that would be 14 days, right? So it makes sense. But what? You gotta count the first day. So think about it in terms of 1 week. Today's Tuesday, right? So if I count today as the beginning, by next Tuesday, I'm not on the 7th day, I'm actually on the 8th day. So by the next Tuesday, I would be on the 15th day? Yeah, okay. So we want the 15th term. These can be a little bit wild, guys. You really have to think about the situations. And the vocabulary of the sentence is huge. You've gotta watch the grammar very carefully. All right, so here we go. Arithmetic, first term is 18. What's the common difference? 3 times 14. So maybe I can do that without a calculator. Is that 60? Help?
I got 60.
So how many will she do? 60. Bless her heart. 60 factoring problems. Sir?
So, in the case that it just said maybe like a week, she only did them on the weekdays, do we just subtract the weekends off?
Yes.
Okay.
Yes. Now keep in mind, my goal isn't to make it as tricky and hard as I can,
Yeah.
so I'm not gonna do weird stuff, but yes. All right, how many will she have done by that day? How many will she have done by that day? Now,
We do this.
is that a sum? So the sum of 15, 15 over 2, first one is 18. Oh, we're in luck. What goes here? 60. We are in luck. We don't have to find anything else. We already did that. Did you get 585?
Yes.
So she will have done 585 problems. All right? Everybody finally made it in, right? So we're all here, good. You all get credit for that homework. Please don't send it in or don't give it to me. I'm giving you credit for it. Okay? Get out your exam review or your test review I gave you. Not your exam review, but the test review that I gave you.
Chapter 9 review.
Yep, the chapter 9 review. Precal A, chapter 9 review. It says due on other paper. All right, we got a few minutes left. I'd like you to look it over. This is your this is all in chapter 9. So this is your probability, all that stuff. So look it over real quick. Get a hand up. Let's do as many of these done as we can. So who sees one you don't know how to do? Who sees one you don't know how to do? Alexis?
Can you do number 11?
Number 11, here we go. There are 5 people in a race. Each of the top 3 finishers will receive $25. How many different ways will the prizes be awarded? All right. Everybody should be looking at me, hanging on my every word right now. Remember, when you have a pool of people or books or whatever it is, when you have a pool and you are going to pick a few out, it's either going to be a P problem, permutation, or it's going to be a C problem, combination, right? Now, there are 5 people in the race. So here are 5 people. 3 of them are going to get a prize. So it's either 5P3 or 5C3. Tell me which one it is. C. Why is it? It's right. Why is it C? They're all getting the same prize. If you're all getting the same prize, then the order that I give you the prize doesn't matter. If I'm going to give both of you $25, does it matter who I give it to first? No. So it's 5C3. All right? You type that in your calculator, write it down. That's the answer. Move on. All right? Who else? Abby? 12. Find the 15th term of this sequence. So this is kind of like what we're doing here. Remember, Abby, in your list of term formulas, there's going to be 2 of them. There's only 2 of them. You have that term formula and you have this term formula. So in order to know which one to use, you have to figure out what kind of sequence you have. So it's 100, 90, 81, 72.9. It clearly is not arithmetic because it's not going down by the same amount. So hopefully it's geometric. How could I figure out if it's geometric or not? What could I do if I can't tell by looking? Sometimes we can tell by looking. If we can't tell by looking, what?
So can't you just divide by 100 divided by 90?
Exactly.
And then you see if it goes down.
Exactly. So I'm going to do 90 divided by 100. What's 90 divided by 100? 0.9. What's 81 divided by 90?
0.9.
So doesn't it look like I'm multiplying by 0.9? So my ratio is 0.9. So the 15th term would be the first term times 0.9 to the 14th. Abby, does that make sense to you?
Yeah.
All right. And I just typed that into my calculator, and it's 22.88, roughly. Who else? Come on, let's go. Alexis? 10. How many different lunches are possible if you must have a sandwich, a fruit, and a drink? So you are going to pick a sandwich and a fruit and a drink. All right? Now, how many sandwiches are there to pick from? 6. So very technically, this is 6C1. There's 6 sandwiches and you're gonna reach in and pick one. Now, 6C1 is just 6. So if you don't wanna do the C part, you don't need to because you're only picking one item. And fruit is 4C1 and drinks are 2C1. So that's 6 times 4 times 2, there's 48 different lunches that you could come up with. All right, another one. Come on guys, please, let's go. We want to review as much as we can. Which one? 8. Find the third, that should say term, not team, sorry about that. Find the third term of 5x minus 3y to the 10. Now, you all know that if we multiplied this thing to the 10th power, we could do it by hand. 5x minus 3y times 5x minus 3y. Here we go, right? It would take forever, but we could do it. Foil, foil, foil. Or we can use that idea of Pascal's triangle and all that stuff we did with combinations to do this problem. Does anybody remember how that works?
Pattern of intermediate x and 10, no y, and then x and 9.
Okay, so Jeff says, whatever these terms look like, they're gonna have a power of 5x and a power of negative 3y. Those are the terms of the binomial, so those are gonna be present in every term. Now, in the very first term, the power on this would be 10. You remember that? Which term am I looking for? The third. So in the very first term, this is a 10. In the second term, it would be a 9. So in the third term, that's an 8? Yes. But if that's an 8, we know this one has to be a 2 because they always add up to that. Now wait, you're not done. There's something missing. Every term has a coefficient. Okay? Every term has a coefficient. In the 10th expansion to the 10th power, the first coefficient is 10C10. The second coefficient is 10C9. And the third coefficient is 10C8. When you expand this thing out, you have all these coefficients. The first one is always, whatever that is, C itself. So 10C10. And then they go down by 1s. Remember that? Until you get to the end of the line and it's 10C0. When you simplify this, this is probably where the most errors come in. When you simplify this, you have to do 10C8, which you can do on your calculator, 45. But then you have to multiply that, not by 5, but by 5 to the 8, which is 390,625. And then times negative 3 to the second, which is 9. Remember, when you set this up, everything in that parentheses gets that power. So you have a 5 to the 8th and a -3 squared. So, the final answer is 158,203,125, x to the 8th, y to the 2nd. Tell me something is coming back to you. You've got some practice to do then, some review to do. All right, what else? We have time to get a couple more done. Let's get some more done. Ollie?
Number 9.
9. Now, 9 is exactly like this, except it is asking me to do the whole shebang. So it's saying, find all the terms, not just the third one or the fourth one or something, but find them all. So basically, Ollie, what I'm gonna do is exactly what I just did, but I have to do it for all the numbers in the row. So, the coefficients are going to be the combination numbers. So 5C5, 5C4, 5C3, 5C2, 5C1, 5C0. I happen to have these memorized, so I'm going to save some time. Instead of having to type them all in, it's 1, 5, 10, 10, 5, 1. That is the 5th row of Pascal's triangle, so if you have the triangle written in your notes so you remember how to get it, you can do that. Now those are the coefficients. Next to those, all of them, you're going to put a 2x and a y. And please put it in parentheses, kids. Otherwise, you're going to be wrong. Put them in parentheses. Okay? Now, what are my powers? I got to put my powers on. What are my powers going to be? What's this one going to be right here? 5, 4, 3, 2, 1. And then what about here? 5, 4, 3, 2, 1, 0. So Ollie, these are the individual terms. Each one of these is a separate term. And now I'll simplify each one. So be careful here. Anything to the 0 is 1, so I can kind of disregard it. But this is not 2x to the 5th. I wish I could supplement my salary with everybody who writes down, if I got 10 cents for everybody who wrote down 2x to the 5th. What is this? 32x to the 5th. What's this one? Be careful now. You've got 2 to the 4th, which is 16 times 5, 80. Gabe's is making sense to you? You see what's happening? So the next one's going to be another 80, I guess. 80x cubed y squared, because that's an 8. What's the next one?
Where is the
10, 40. I know I went through that kind of fast. I'm trying to get one more problem done. That one takes a while.
And that's as simple as you can get it.
Yeah, I mean, none of those are like terms, right? We can't combine anything.
Question, I'm just trying to logically think. How is 5C3 and 5C2 the same number?
Think about that. I'm glad you asked that question. Think about that for a second. 5C3 means, for example, that there are five kids in the room, and I'm going to pick 3 of them.
Mm-hmm.
Okay, so let's suppose there are only 5 kids in the room.
Okay.
If I pull 3 of them out into the hall, haven't I automatically moved the other 2?
Okay, yeah.
Absolutely. Good question. All right, one more problem, and I promise I'll shut up. One more. One more. 18. An ice cream shop has 8 different toppings. You can get 3 toppings on a Sunday. How many different combinations are possible? So you know how that is. You walk into the ice cream shop and they've got their sprinkles and their chocolate chip, you know, all this stuff. Your mom says, okay, I'll pay for free. You get free. So there's 8. You're picking 3. It's either a P or a C, kids. Is it a P or is it a C? For a normal human being, it would be a C. Because most people do not care if we put the chocolate chips on before the sprinkles or whatever, right? So we're going with normal. It's going to be 8C3. 8C3. There are 8 toppings. You are choosing 3 of them, and the order that the guy dumps them on doesn't matter. Okay? All right, I am about ready to become either the most popular teacher in the world or the least popular teacher in the world. The next time